Hey, welcome back. I hope you're enjoying these videos as I work the problems. If you're liking it, go ahead and hit the like button and subscribe. So here we go. 1.3, exercise 3. So it says identify the segment bisector of line segment RS. Well, obviously we know a segment bisector can be anything that cuts our segment into two equal parts. So we look, these mean equal parts. So what would we call this? Well, line K. Alright, so it says the length of RS is also something that we need to find. Well, if this is 17, then this is also 17 because bisect means two equal parts. 17 plus 17 is 34. Alright, next. Identify the segment bisector of JK. Well, this guy right here, point M. Now we know bisector means that this is equal to this. So let's write that. 7x plus 5 equals 8x. If you remember DC SADMEP from our last episode, let's get these like terms together. I need to move them by doing inverses. So we subtract. Inverses cancel. So I get 5 equals 8 minus 7, which is x. Cool. But it wants to know JM. Well, JM is this part right here. So plug in 5 for x. 7 times 5 is 35. Plus 5 is 40. Exercise 9. Identify the segment bisector of XY. Well, here's XY. So it's this thing here. That would be ray MN. And we know segment bisector means two equal parts, so I know that 3x plus 1 equals 8x minus 24. DC SADMEP this mug. Here we go. Move your 3x. Cancels. 1 equals 5x minus 24. Add the 24. 1 plus 24 is 25. And this is 5 times x, so we're going to divide. So 5 equals x. Yes, that is a 5, not an s. Is that better? Okay. So then it wants to know, what is xy? Well, here's the whole thing. So we're going to plug in 5 here for x. 3 times 5 is 15, plus 1 is 16. But since it's a bisector, it means they're both equal parts. So if this part's 16, then this is 16. And that would make the whole thing 16 plus 16, which is 32. So we know that the endpoints of something are this and this. Now, for whatever reason, midpoints can be difficult. But we have to really just think about what's happening. Well, I've got some point here. I've got some other endpoint here. And I've got to find the middle. So basically you're asking yourself, well, how do I go from here to here and then here to here? What is an equal distance to travel? Well, if the whole distance is 4, and each of these is a half of 4 is 2. So our distance from here to here was 4. Half of that is 2. Well, 3 plus 2 is 5. Okay. Now, we got to figure out, well, what's the distance from here to here? Well, if you think on a number line, I basically have to count 1, 2, 3, 4, 5 to get to 0. 6, 7, 8, 9, 10, 11, 12, 13, 14 to get to 9. So the distance between this and this is 14. So again, since it's the middle, each part is half. Well, half of 14 is 7. So negative 5 plus 7 is 2. So again, midpoint. We're just trying to find the middle between the 2 points that they give us. All right, similar problem here. I've got some endpoint at 3, negative 5. I got some other endpoint at 7, 9. And I want to know what's the middle. So again, How far is it from 3 to 7? Well, it's 4. Now, you know what I just realized? This is the same problem. So we're skipping it. Psych. All right, moving on. So it says the coordinates of the midpoint of GH. So I've got some line segment GH. And the midpoint is 4, 3. So the middle is 4, 3. It tells us that this is 5, -6. So we got to figure out, well, it's H. So we figure out now, since it's the midpoint, we're just asking ourselves, how far is it from here to here? Well, it's going down 1. So if that's halfway, then we would go down another 1 again. Well, 4 minus 1 is 3. But then we also have to ask ourselves, well, how far is it from here to here? You can think about that as a coordinate plane if you plotted these points, or you can think about it as a number line. Well, to go from -6 to 3 is to go 9. But since this is the midpoint, I know it's +9 to get to here. That would mean it's another +9 to get to here. Well, 3 plus 9 is 12. And there you go. There's your midpoint. So, same problem here. Let me check to make sure it's not the same one again. It's not. We're good. So, I've got some line segment GH. It tells me that the midpoint M is at 8, 0. And then it tells me that it's -2, 9 here. And I basically have to find what GH is. So, since this is the midpoint, we just have to find out, well, how far on the number line or coordinate plane are we moving from here to here? Well, to get from -2 to 8, you have to go up 10. Well, if it was +10 to get to the middle, it's going to be another +10 to get to the other side. 8 plus 10 is 18. Now, similarly, how far is it from 9 to 0? Well, you have to go down 9. We're going down 9. So if it's down 9 to get from here to here, it's got to be another down 9 to get from here to here. Well, down 9 from 0 is -9. And there is our point G. Distance. Okay. Well, the distance formula is just x2 minus x1 squared plus y2 minus y1 squared. And we get to pick the x1 and the y1. I don't know. Let's just go x2, y2, x1, y1. And we're going to plug in. So 13 minus 7. Oh, what the heck. Let's color code this. There we go. Plus, well, y2, which is 2, minus y1, which is 10. And now we just simplify. 13 minus 7 is 6. 2 minus 10 is -8. 36 is 6 squared plus 64. Don't forget, this is all under a square root. 36 plus 64 is 100. Square root of 100 is 10. So the answer here is 10. Now, when it's asking for the exact distance like we have on number 25, let me erase this, clear some space for us. We'll leave the distance formula. We're going to need that again. Basically, what we're looking to do is we are trying to figure out the distance again. So let's plug it in. Let's make this x2, y2, x1, y1. Again, I can pick whatever I want. I just usually do that. So we've got 3 minus 6 squared plus 7 minus 5 squared, all square root. 3 minus 6 is -3 squared plus 7 minus 5, which is 2 squared, all in the square root. -3 squared is just -3 times -3. which is 9. 2 squared is 4. 9 plus 3 is 13. So our answer here is square root of 13. Last one. Well, actually, I guess we have 2 more with distance. Sorry. Let's look at another one. Clear some space. Now, hopefully, each time you're writing the distance formula, I've written it enough times in my life that I basically have nightmares about it. I'll be waking up at night and my wife will be screaming about, the distance formula. Pretty sure she has it memorized too. So, I don't know. Let's go x2, y2, x1, y1. And maybe for the last one, we'll change it up. Who knows? Alright, so I've got negative 8 minus 1 squared plus 0 minus 4 squared. That's a negative 9 squared plus negative 4 squared. That's 81 plus 16. Don't forget this is all under square root. 81 plus 16 is 97. Well, I'm not sure what movie it's from, but they're like, I can go the distance. Something. Maybe it's Mulan. I don't know. Anyway, we just went the distance. We found our answer. Let's go the distance again. We're going to change it up this time. x1, y1, x2, y2. Again, does not matter. x2 minus x1 squared plus y2 minus y1 squared, square rooted. 6 minus 0 is 6. 3.5 minus 1 is 2.5 squared. So that's 36 plus 6.25 square root. So square root of 42.25. Okay. We've gone the distance. We've conquered the distance formula. Now I've got to deal with inequalities. So let's just give ourselves some more space. Here we go. Minus 18, minus 18. A is less than negative 11. That looks like this on a number line. Open, arrow pointing this way at negative 11. 51. Add 5, add 5. Y is greater than or equal to 13. That is a closed circle, arrow pointing that way at 13. Now, don't forget, when you divide by a negative, not sure what happened there, our sign flips. So it actually goes this way. So we are open at negative 8, arrow facing that way. And our last one. Multiply by 4, multiply by 4. That's 48. Go to 48. Closed. Arrow pointing that away. By the way, 48 is right here. It's this one. This one right here. Okay. I hope you enjoyed it. I enjoyed making it. See you next time.